All right, so can we say that the slope here is going to be the difference in your y's? So I'm going to go 4 minus -3. Is that okay with everybody? We're talking about how we subtract our y values for our slope, and now we're going to subtract our x's, right? So 1 minus -2. What's 4 minus -3? 7. What's 1 minus -2? 3. So there's my slope. So that's the m value that when we go y minus y1 equals m times x minus x1, that 7/3 is going to go right there. Okay. Now I need a point that is also on this line. What points are you pretty confident about being on that red line?
The ones right there.
What do you mean the ones right there?
Like -2, -3.
Okay, so the ones that it gives you, you know that those are on your line, right? Okay. Now some people earlier in the day were saying, oh, well, I know that point right there is on my line. And you do know it's on your line. But do you know what the coordinates of that point are?
No.
No, it's 0. Anyway, you're gonna find out it's 0, 5/3 eventually. Okay? Nobody would have probably guessed 5/3 for that. Does it make sense? Okay. You know, all of these points that I'm coloring green, we kind of have to guess their ordered pair. But the ones they start me with, I don't have to guess. I know their exact ordered pair. So I'm going to use those. Okay. Now it doesn't matter. So right now I'm just going to choose 1, 4. Okay. So that 1 is your x1. And that 4 is your y1. Does that make sense? And you just plug that stuff in. So I'm going to go y minus 4 equals 7/3 x minus 1. And that's my equation. Okay. Huh?
That's hard.
That's hard. So all you're doing there is finding slope, something you already know how to do, right?
Yeah.
Then you're just recognizing a point that is on that line, right? Choosing 1, 4. And then you substitute the x and the y from 1, 4 into x1 and y1. That's all you gotta do. Okay, my hope is that we realize there that those are, maybe it's 3 steps, but there are 3 steps that we've already worked on in regards to substitution. We already learned how to do that in chapters 1 and 2 in 7th and 8th grade. Slope we worked on last year. We're working on again this year. I already know how to do that. Okay. The next part is where I'm going to argue that that's a little bit more difficult. But again, it's what we already know how to do this. It's just the algebra involved that. Or arithmetic that we struggle with sometimes. But what I want to do just real quick before we move on, I'm going to check this. Okay, so we knew that 1, 4 was on that, right? And we knew -2, -3. Those were my 2 ordered pairs. Okay, we just wrote the equation y minus 4 equals 7/3 times x minus 1. Does that line go through those 2 points? No other line will ever go through those 2 points. Does that make sense? That is the only one. That's the one and only one. Now, let's do this because I told you it didn't matter. It didn't matter the point you chose. So let's do this if I would have chose the point -2, -3. Still going to go y minus y1 equals m times x minus x1. So now y1 is your -3, right? So what's minus the -3? If I write minus -3, what's that actually turn into? +3. So y plus 3 equals m Well, m is still this 7/3. It's still the same line. So 7/3. And now x is going to be minus a negative 2 because we're going to use that x value right there. What's minus a negative 2 going to look like? Positive 2, right? X plus 2. Does this thing in yellow look differently than that thing in green? Yes. Okay. So the argument is, let's say that Annika does the one in green, let's say Ollie does the one in yellow, and they're comparing their answers, and they look at each other and say, well, one of us is right, the other one's wrong. But if we graph these, if we graph this, y plus 3 equals 7/3 x plus 2, does the purple one land on top of the green one? Okay. So that tells me that these two things are the same line. And now the algebra that we go through here in a moment is going to kind of validate that. It's going to convince us that those indeed are the same thing. And the reason they're not looking the same thing right now is because y is not by itself. If we put y by itself, we should be able to recognize that those are identical. But that's the thing. When you're doing this in your homework and they ask you to write your answer in, and they're going to use the notation, they're going to use the vocabulary, they're going to say, put it in point slope form, meaning use a point, x1, y1, and use your slope. When they say put it in point slope form, they will accept either one of those. Does that make sense? Okay. The next thing they will do on most of those questions is once you have it in point slope form, they will say rewrite the equation in slope intercept form. Okay, now here's my question. What is slope intercept form? You need a slope, right? Yeah. Need a slope, so that's mx. What's an intercept? What do we call, what was the intercept that we used? Yeah, it was the y-intercept, so it's going to be plus b. So that slope intercept form, when they say that, it's their way of saying, put it in the y equals mx plus b form. So if I look at those two equations that I've highlighted, let's just pick off the green one right now. If I look at that green one, it's not in y equals mx plus b form, right? Because the y is not by itself. So let's take that let's take the green one first. Take the green one, and let's see if we can put that into y equals mx plus b form. So I'm going to go y minus 4 equals 7/3 x minus 1. Okay? We want to get y all by itself, right? How do I go about, what are the steps that you would go through to get y all by itself? Okay, I'm going to add 4 to both sides. Okay? So if I add 4 here, that's going to give me y, right? Now I'm going to add 4 to the right-hand side. Okay? Now, because this is a product here, because that's a product, we're just going to rewrite this as 7/3 x minus 1 plus 4. Does that make sense? There's no, we don't know what the like terms are yet. Okay? I'll show you a different way. When we do the next one, I'll show you a different set of steps you can go through. Okay? But this idea here is, if I have 7, let's take 7/3 and rewrite it as, let's go, 7/3 is 2.3 repeating. Okay, so really what I've got here would be like y minus 4 equals 2.3 repeating. Let's say x was like 11. So then x minus 1 would be 10. Does that make sense? So this thing right here is actually a product of two numbers, maybe 2.3 and 10. Does that make sense? Mm-hmm. If I were to solve for y, what would you do?
Add 4.
You would add 4. Where would you add 4? Would you add it to the 2.3? Yeah. Would you add it to the 10? Yeah. Or would you add it after you do that multiplication. Would you add it to the 23 that is there instead of 2.3 times 10? You would add it to the 23. You got order of operations, you need to do that multiplication first, right? Okay, so if I were to add the 4 to this, I'm going to get 14 times 2.3. And that's not the same thing that I should get. I should get 27 when I do this. Okay? If I take 14 times 2.3, it doesn't give me 27. It gives me something bigger than 28. Okay? If I add 4 to this, it's 6.3 times 10. That gives me 63. Okay? I wanted the 27, right? So order of operations tells me that I can't, and I just want to make sure we understand, because I get people to do this. When I add 4 to both sides, a lot of people want to go right there to that -1 and add 4 to it. You can't do that. Okay? So now, does this say I can distribute that? Does that make sense? So I'm going to distribute that. So I get 7/3 x minus 7/3 plus my 4. Now that I've distributed, now I can see that those things in yellow are like terms, right?
Yeah.
And here's where I want to urge you guys, because we're missing a lot of these questions with fractions and they're creating issues. Make sure that if you got your technology, use your technology. I know I've told you to learn how to add fractions and that kind of stuff. If you're struggling with it and that's creating an impasse for you to get right answers, use Desmos. Type in -7/3 plus 4. You see that little button right there? It's got that box, the division bar in a box. That means change it to a fraction. Okay, well, however you highlight it, it goes back and forth between decimal and fraction. So what I've got highlighted there in yellow is then 5/3, right? So now I get y equals 7/3 x plus 5/3. Is that y equals mx plus a b?
It is.
Okay. So now I've got that in that format. Okay. But what I want you to understand is that y minus 4, what we start with, y minus 4 equals 7/3 x minus 1, is really the same thing. We just got to do a little bit of work to get to that, right? Let me do this. Because I told you it didn't matter which one. So let's say we had, what we had, the other one was y plus 3 equals 7/3 x plus 2. Okay? Now, in this one we added 4 to both sides, right? And then distributed? Okay? Those two steps are actually independent of one another. Meaning, you can either subtract 3 from both sides here first, and then distribute the 7/3, or you can distribute the 7/3 and then subtract 3. My thought is that people are actually a little bit more successful by distributing this 7/3 first. Either way you do it, you're going to have to distribute at some point. So 7/3 times x is 7/3 x, right? 7/3 times 2, what's 7 times 2? 14. What's 3 times 1? 3. So now I got y plus 3 equals that, right? How do I get this y by itself? Subtract 3. So now I'm going to have 7/3 x plus my 14/3 minus 3, right? Are these two terms able to be combined? Yeah. So let's go to Desmos. Let's go 14/3 minus 3. Does it still give me 5/3? So with these two things added together, these two go to 5/3. So then I have y equals 7/3 x plus 5/3. Is that the same as that? Okay, so what does that tell me then? What does that tell me about these two things then? They're the same. Even though they have different y1s and x1s, when we go through the algebra and solve for y, they both turn out to be y equals 7/3 x plus 5/3. Go back to your graph real quick. Okay? We said our y-intercept was a value that we would have had it guessed, right? That's why we didn't use the slope-intercept form, because this coordinate right there, we know its x is 0, but we didn't know the y value. But now we know that y value is 5/3, right? Okay, and my argument is right off the bat, I don't think anybody would have guessed that. Okay. So when you don't know the y-intercept, okay, or maybe the y-intercept's a really nasty ordered pair, or essentially a nasty y-value, this point slope format is the tool that we want to use. Okay. Now, I just want to show you, don't have to write this down, but I want to show you something real quick. Let's say that I've got that there, I've got this blue line, okay, and there's a point on that blue line. I'm just going to call it x comma y. Okay, so I don't know the coordinates, I don't know what the numbers are, but they're an x value and a y value. That's how I get from 0, 0 to that point, right? Move some x distance, move some y distance, right? Okay, let's choose that point right there. Let's call that my x1, my y1. Okay, can I find the slope between those two things?
Yeah.
Yeah, so the slope between those two things is still rise over run, so it's still m. Does that make sense? Okay, so now I'm gonna go this. I'm gonna go y minus y1 equals m times x minus x1. This slope here is the rise over run that I'm able to figure out between those 2 points. Okay, now here's my question. This point right here is what kind of point?
What point is that? 0. It's a y-intercept.
It's a y-intercept. So what is this x? What is this x1 value?
The x1 value. 0.
0, right?
Yeah.
Okay. What did we call the y1 value? If I didn't know what it was, what was the letter we used for it?
4. B.
B. Okay. So now let's go back. Let's go to this equation. So this x1 and y1, we just redefined our variables. We just stated what they were. Does that make sense? Use different letters. Okay. But x1 is 0, y1 is b. So let's plug that stuff in here. Can I go y minus y1 and y1's b? M x minus x1, but x1 is 0. X1 is 0, right? Let's do that math. I get y minus b is equal, what's m times x? mx. What's m times 0? 0, right? Solve this thing for y now. How do I solve for y? Plus b. Do you see that this equation, y equals mx plus b, comes from y minus y1 equals m times x minus x1 when x1, y1 is a y-intercept? When it says 0 comma b? Does that make sense? So what I want you to know, that's the math, guys. Everything else we're doing is arithmetic. That's the math that says these two formulas, even though they ask us to use different formats periodically, they are identical. They're the same thing. Okay? In your homework, make sure that you understand if they use the word point slope, you're going to type it in like this. Okay? If they say slope intercept, you type it in like this. Okay? Tonight there is no new homework. Okay? Tomorrow I'm going to give you kind of a little bit of a break, but you still have, some of you have the worksheet from Thursday, some of you have the 5-2 from yesterday. Make sure you finish those up. But no new homework on top of that. Tomorrow we'll finish this section. My goal is, guys, once we get this information learned, to go back and just do a couple days of just practice problems. Okay? But I want to make sure we learn all the information first, get exposure to it, and then go back and drill it. It's very, very important stuff here.